Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on lowest common multiples, or LCM, and the highest common factor, so the HCF. In this video, we're going to be looking at the video solutions to the practice questions. If you need any extra help on lowest common multiples or highest common factors, this video tutorial is on Corbettmaths, so if you go to the videos and worksheet section and scroll down to video numbers 218 and 219, there's dedicated video tutorials there on the lowest common multiple and the highest common factor. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, so question number one. So question number one, we've got this box of numbers with 12, 40, 28, 64, 100, 35, 6, 18 and 38. And from the box above, we've been asked to choose two numbers that have a common factor of 10. That means they're both divisible by 10, so it means they're in the 10 times table, such as 10, 20, 30, 40 and so on. So we want to find a number that ends in a 0, because if there's any numbers here in this table that end in a 0, they're going to be divisible by 10. So as you can see here, 40 ends in a 0, so it's divisible by 10, so 40 has got a factor of 10, and another number that's got a factor of 10 will be 100. So both 40 and 100 have a common factor of 10, they're both divisible by 10. Okay, let's look at our next part, part B. So part B, we've been asked to find two numbers from the box above that have a common multiple of 24. So that means that if you consider the multiples of those numbers, 24 is going to be a multiple of both of those numbers. So in terms of this, I'm going to start off with numbers that are 24 or less, because for instance, I'm not going to consider 28 because the first multiple of 28 would be 28. So here, in terms of numbers that have a common multiple of 24, I'm going to think of numbers in the table that are less than 24. So the numbers that jump out to me are 12 and 6. So let's consider 12. 12, 24, 36, and so on. 6, we've got 6, 12, 18, 24. And as you can see, 24 is in both of those lists. So both 12 and 6 have got a common multiple of 24. So 12 and 6. Okay, let's look at our next part, part C. Okay, let's look at our next part, part C. So part C says, find two numbers from the box that have got a common factor of 7. So we want to have a look at these numbers, and we want to look for numbers that are divisible by 7. So 12, no. 40, no. 35, yes, because 7, 14, 21, 28, 35. So 35, yes. 6, no. 18, no. 38, no. 100, no. 64, no. 63 is, but not 64. 28, so 28 because 7, 14, 21, 28. So that's it. So the two numbers from the box that have a common factor of 7 would be 28 and 35. They're both divisible by 7. Okay, let's have a look at our last part, part D. So part D, we're going to be looking for two numbers from that box that have got a common multiple of 200. So in other words, if you write down their multiples, 200 would be in both lists. So let's have a look at the numbers in the table. So in terms of the numbers in the box, we want to find numbers that whenever you write their multiples, you're going to get the number 200. So I'm looking here at 40, because 40, 80, 120, 160, 200. And also 100, because 100, 200. So let's write those down. We would have 40, 80, 120, 160, 200, and for 100 it'd be 100 and 200. So two numbers that have got a common multiple of 200 from that box would be 40 and 100, and that's it. Okay, let's look at our next question, question number 2. Okay, so question 2a says, list the factors of 28. So I'm going to consider the factor pairs. So 1 times 28 is equal to 28. So 1 and 28 are both factors of 28. 2 times 14 is equal to 28. So 2 and 14 are also factors of 28. And then 3, no. 4 times 7. 4 times 7 is 28. 5, well, 5, 10, 15, 20, 25, no. 6, no. And then 7, so we've got to that number. So we've got all the factors there. 1, 2, 4, 7, 14, and 28. So let's write them down. 1, 2, 4, 7, 14, and 28. So there are all the factors of 28. Okay, let's look at part B. Part B says write down the highest common factor of 21 and 28. So we've got the factors of 28. Let's write down the factors of 21. So the factors of 21 would be, well, the factor pairs 1 times 21 is equal to 21. And also 3 times 7 is equal to 21. And they're all the factors. So the factors of 21 are 1, 3, 7, and 21. Now we're trying to find the highest common factor of 21 and 28. So let's circle the common factors. Well, 1's a common factor, and also 7's a common factor. And they're all the common factors, 1 and 7. So we're trying to find the highest common factor, so that would be 7. So that would be 7. 7 is the highest common factor of 21 and 28. Okay, let's have a look at our next question, question number 3. So question number 3, we've been asked to find the highest common factor of 12 and 16. So let's write down 12 and 16 and then list their factors. So the factors of 12 would be, well, we've got 1 times 12 is equal to 12, 2 times 6 is equal to 12, and 3 times 4 is equal to 12, and then we've got to 4, so there are all the factors of 12. So 1, 2, 3, 4, 6, and 12. Okay, now let's consider 16. We've got 1 times 16, 2 times 8, and 4 times 4. So the factors of 16 would be 1, 2, 4, 8, and 16. So they're the factors of 12 and 16. Now we want to find the highest common factor. So let's circle the common factors. So 1's a common factor, 2's a common factor, 4's a common factor, and that's it. So the highest common factor of 12 and 16 would be 4. And that's it. Okay, let's look at our next question, question number 4. So question number 4, we've been asked to find the lowest common multiple of 9 and 12. So 9, the multiples of 9 would be, well, we've got 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, and so on. So they're the multiples of 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, and so on. Okay, the multiples of 12, so the multiples of 12 will be 12, 24, 36, there we'll find the lowest common multiple there, 36, 48, 60, 72, and so on. So in terms of the lowest common multiple, well, as you can see here, we've got common multiples of 36, 72, and so on, but we're trying to find the lowest common multiple. So the lowest common multiple would be 36. It's the first number that's in both the lists of multiples of 9 and 12. So the answer is 36. 72 would be a common multiple, but it's not the lowest common multiple. Okay, let's look at question number 5. So question number 5 says, write down two numbers that have got a highest common factor of 10. So we want to find two numbers that have got a highest common factor of 10. So I'm thinking 20 and 30, because if we have 20 and we've got 30, they're both divisible by 10 because they both end in a 0, so we can divide both of them by 10. They're both in the 10 times tables. In terms of the factors of 20, the factors of 20 would be 1 and 20. They would be 2 and 10 and 4 and 5. So they're the factors of 20, 1, 2, 4, 5, 10, and 20. The factors of 30 would be 1 and 30, 2 and 15, 3 and 10, and 5 and 6. So they're the factors of 30. And let's just check them. 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And then in terms of those lists, as you can see here, 10 is the highest common factor. It's the biggest number that they're both divisible by. So two numbers that have got a highest common factor of 10 would be 20 and 30. You could choose other numbers. You could, for instance, choose 10 and 50. 10 would be a good number to choose. So 10 and then another number, for instance, such as 60 or 70 or something like that. But I've gone for 20 and 30. Okay, let's have a look at our next question, question number 6. So question number 6 says that a red light flashes every 6 seconds and a yellow light flashes every 4 seconds, and they both flash at the same time. And we've been asked after how many seconds would they both flash at the same time. So they've both flashed, so let's consider the red light. The red light then will flash again in 6 seconds, and 12 seconds later, and 18 seconds later, it's just red there, and 24, 30, and so on. The yellow light, it'll flash again after 4 seconds, and 8 seconds, and 12 seconds, and 16, and 20, and 24, and so on. And as you can see, they're both going to flash again at the same time after 12 seconds, because that's in both of the lists. They'll also flash again together in 24 seconds time, but in 12 seconds time, that'll be the next time that they'll both flash again at the same time. So the answer will be 12 seconds, and that's it. Okay, let's look at our next question, question number 7. So question number 7 says, Tilly the dog barks every 9 seconds and Billy the dog barks every 12 seconds, and they both bark at the same time. After how many seconds will they both bark again at the same time? Okay, so these poor dogs are barking every 9 seconds and 12 seconds. So Tilly, so I'm just going to write down Tilly here, and I'm going to write down the multiples of 9 because she barks every 9 seconds. So 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, and so on. And Billy the dog barks every 12 seconds. So every 12 seconds it's going to be 12, 24, 36, 48, 60, 72, 84, and so on. Now it says after how many seconds will they next bark at the same time. So let's look for the lowest common multiple. And as you can see here, that's going to be 36. That's after 36 seconds. And that's it. So both dogs will bark again after 36 seconds, unless someone goes to see them and see why they're barking every 9 and 12 seconds. Okay, let's have a look at our next question, question number 8. Okay, let's look at our next question, question number 8. So question number 8 says that black pens are sold in packets of 10, red pens are sold in packets of 4, and green pens are sold in packets of 3. And Mina wants to buy the same number of black, red, and green pens. And we've been asked to work out the smallest number of each pack she should buy. So let's consider them. So in terms of the black pens, they're sold in packets of 10, so she could buy 10, 20, 30, 40, 50, 60, 70, 80, 90, and so on. I'm going to leave a bit of room here in case I need to carry on that list. Red pens, they're sold in packets of 4, so red pens sold in packets of 4, so she could buy 4, 8, 12, 16, 20. That's good. It's in both of the lists here for black and red, but green we're going to be rounding down the multiples of 3, and I know that 20 is not in the 3 times tables, so I'm going to have to carry on this list here. So 24, 28, 32, 36, 40, 44, 48. I'm going to carry on a little bit here. 52, 56, 60, 64, 68, 72, 76, 80, 84, and so on. And green pens, again, I'm going to leave a bit of room here just in case. So green pens, they're sold in packets of 3. So we've got 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, 66, 69, 72, 75, and so on. I'm just going to stop there for a second. So we want to find how many pens Mina can buy. So she wants to buy the same number of black, red, and green pens. So we want to find the lowest multiple of 10, 4, and 3. So here, if we look at these, now the multiples of 10 are quite straightforward. They end in 0. So let's look at the red and green pens and look for the numbers that are in both of those lists that end in a 0. So here we've got 20. No. We've got 40. No. We've got 60. Yes, there it is. And also there too. So 60. So that means that she can buy 60 black, red, and green pens because they're sold in packets of 10, 4, and 3. So we need to make sure that the number of pens she buys will be a number that's in the 10, the 4, and the 3 times tables. So the lowest multiple of 10, 4, and 3 is 60. Now the question is, how many packets should she buy? So let's look at the black pens. You need to buy 1, 2, 3, 4, 5, 6 packs of those. The red pens, well, they're sold in packets of 4, and I know that 4 times 15 is equal to 60, so it should be 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep. And then the green pens, well, 3 times 20 is equal to 60, so it should be 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that means that Mina should buy 6 packets of black pens, 15 packets of red pens, and 20 packets of green pens. And that means she'll buy 60 black, red, and green pens. And that's it. Okay, let's look at our next question, question number 9. Okay, let's have a look at our next question, question number 9. So question number 9 says that Mr. Jones repaints his fence every 6 years, and he repaints his front door every 9 years, and he repainted both his fence and his front door in 2025. And the question says, when is the next year that he will repaint both his fence and his front door? Okay, so he repaints both of them in 2025. So I'm just going to write down here the fence and also the door. And he repaints them both in 2025. So every 6 years he repaints his fence. So I'm just going to add on 6, add on 6, add on 6, and so on in terms of the fence. So if we add on 6 more years, so 25 plus 6 is 31, so it's going to be 2031. Adding on another 6 would be 2037. Adding on another 6 would be 2043. Adding on another 6 would be 2049, and so on. In terms of his front door, he repaints that every 9 years. So if we add on 9, so 25 plus 9 is 34, so 2034, no. Adding on another 9, well, 34 plus 9 is 43, so 2043. Yes, we've found the number. So the year would be 2043. So in what year will he next repaint both the fence and the front door? as long as he lives in the same house, would be 20, 43. And that's it. Now, some people may have considered the multiples of 3 and the multiples of 9 and found that the lowest common multiple is 18, and then just added 18 onto the year, and then that'll be 20, 43 as well. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 10. So question number 10 says, write down 3 numbers that have got a lowest common multiple of 24. So we're looking for 3 different numbers that have got a lowest common multiple of 24. Now, one good number to choose here could be 24, because we know if that we write down the multiples of 24, 24 is going to be the first one that we write in that list. But I'm going to start off with 3. So 3, well, the multiples of 3 would be 3, 6, 9, 12, 15, 18, 21, and 24. So that's one of the numbers that I'm considering to begin with. Now, actually, what I'm going to do is I'm going to think of the factors of 24. The factors of 24, I'm just going to write them up here. Factors of 24. So we'd have 1 and 24, because 1 times 24 is 24. We would have 2 times 12 is 24. We would have 3 times 8 is 24. And we would also have 6 times 4 is 24. So they're the factors of 24. Okay, so I've chosen 3. Let's have a look at another number. I'm going to choose 8 here. So if I've got 8, the multiples of 8 would be 8, and then we'd have 16, and then 24. So that would be a good choice, because here we've got that 24 is in both of those lists. And then actually another one I'm going to choose here, I could choose 24 here. That would be a nice one to choose, because if I wrote down 24, then I would just write down 24. So as you can see, 3, 8, and 24, they have got a lowest common multiple of 24. It's the first number that's in all of those lists. I could have perhaps chosen another number there, such as 12, because if we wrote 12, it would be 12 and 24. And so even though 12's in that list, it's not in this one, so then 24 would be the lowest common multiple. But I've just chosen 3, 8, and 24. And that's it. Okay, let's look at our next question, question number 11. Okay, let's look at our next question, question number 11. So question number 11 says, Rosie and Sophie jog around a rectangular hockey pitch for 45 minutes. They place an orange cone at the starting point and they begin running at the same time. Each lap takes Rosie 2 minutes and each lap takes Sophie 100 seconds. And after they start running, how many times do Rosie and Sophie pass the orange cone at the same time? So we've got this orange cone perhaps in the corner, and they're going to be running around the pitch. And as you can see here, Sophie is slightly quicker than Rosie because it takes her 100 seconds, whereas it takes Rosie 120 seconds. And there's going to be certain times whenever they pass that cone at exactly the same point, and we need to find out how many times they pass that cone at exactly the same time. And one other thing to consider is that they actually just run for 45 minutes. So we need to think of the common multiples of 120 seconds and 100 seconds up to, and actually I'm just going to change the 45 minutes into seconds as well. So I'm going to do 45 multiplied by 60, and that's equal to 2,700 seconds. So you want to find out how many common multiples 100 and 120 have up to 2,700 seconds. Because we know that Sophie's going to pass the orange cone at 100 seconds, 200 seconds, 300 seconds, 400 seconds, 500 seconds, 600 seconds, and so on. But that one's quite easy. With Rosie, it's going to be 120 seconds, 240 seconds, 360 seconds, and so on. And there's going to be certain times whenever they pass that cone at exactly the same point. And we just need to go up to 2,700. Now, Sophie's quite straightforward. We know that for Sophie, it's going to be 100, 200, 300, and I'm actually just going to list all of them out here because I'm trying to show you the model solution. So 400. So that's it. And actually I've written down all the times, and as you can see, actually at the end of the 45 minutes, Sophie stops at that orange cone. Now in terms of Rosie, she passes that orange cone every 120 seconds. So on my calculator, what I'm going to do is I'm going to press 120 and then press equals, and I've got 120 there. And then what I'm going to do is I'm going to press answer, which is 120, the start number, and then it's going to do plus 120. And every time I press equals, it's just going to keep on adding 120. So we know that it's going to be 120 to begin with, and then if we press equals, or exe, we get an answer of 240, 360, 480, 600. That's going to be one of them, because remember that Sophie's every 100 seconds, so every time Sophie passes the cone, it's a multiple of 100. So that's going to be 1. So after they start, so they at 600 seconds, they pass that orange cone at exactly the same time. 720, 840, 960, 1080, 1200. That's 2 occasions that they pass the orange cone together. 1,320, 1,440, 1,560, 1,680, 1,800. So we've had 600, 1,200, 1,800. You can see here the common multiples at every 600 seconds. So the next one's going to be 2,400. So, and then we're only gone up to 2,700. So then that's it done. So there's going to be 4 occasions. They're going to be at 600 seconds, which is 10 minutes, and then 1,200 seconds, which is 20 minutes, 30 minutes, and 40 minutes. So the question says, after they start running, how many times do they pass the orange cone at the same time? The answer will be 4. And actually, I'm just going to write down the multiples here. And I'm just going to circle them. So 600 and 600, 1,200, 1,200, 1,800, 1,800, and 2,400, 2,400. So there's 4 occasions whenever both of those girls pass the cone at exactly the same time. And that's it. Okay, let's have a look at our next question, question number 12. So question number 12 says, a blue light flashes every 8 minutes while a pink light flashes every 54 minutes, and both lights flash together at 2 p.m. When is the next time that both lights will flash together again? And this is a calculator question, so that's going to make it a wee bit easier for us. Okay, now one way I could approach this is, I could write down all the multiples of 8 and all the multiples of 54, and then look for both of the numbers in both of those lists. Now in terms of the multiples of 8, there's going to be quite a lot of them here. So what I'm actually going to do is I'm going to write down the multiples of 54 to begin with. So I'm going to write for the pink light, it flashes every 54 minutes. So it's going to be 54. Adding another 54 would be 108. Adding another 54 would be 162. Another 54 would be 216. Another 54 would be 270, and so on. And then in terms of the blue light, it flashes every 8 minutes. So because we'll be writing down the multiples of 8, then what I know is that if the numbers are going to be in both of the lists, that the common multiples must be a multiple of 8. So what I'm going to do is I'm going to check and see, are these numbers divisible by 8? So are they a multiple of 8? So multiple of 8, question mark. And let's divide them by 8 and see what we get, because it's a calculator question. So 54 divided by 8 is equal to 6.75, so no, that's not a multiple of 8. 108 divided by 8 is equal to 13.5, so that's not a multiple of 8. 162, if I divide that by 8, I get that's equal to 20.25, so that's not a multiple of 8. 216 divided by 8 is equal to 27, so yes, that is a multiple of 8. So if I was to write down all the multiples of 8, I would get to 216 before I'd find one of the numbers that's in both of this list and the multiples of 8. So this is just a bit of a quicker way to do it. So I just checked whether these numbers were divisible by 8, and because 216 is the first one that's divisible by 8, it will be the lowest common multiple of 8 and 54. Okay, now the question says, at what time will both lights flash together at the same time? Now it's 2 o'clock whenever they flash together at the same time the last time. So I'm going to change the 216 minutes into hours and minutes. So hours would have 60 is 1 hour, 120 is 2 hours, 180 is 3 hours, 240 would be the next one, so it's going to be 3 hours, so 3 hours, and that's 180. 216 take 180 is equal to 36, so 36 minutes. So it will take 3 hours and 36 minutes for them both to flash again at the same time. Now they both flash together at 2 o'clock, so we need to add that on, so that's going to be 5:36. So 5:36 p.m. and that's it. Okay, let's look at our next question, question number 13. Okay, so question number 13 says, Mary's organising a charity hot dog sale, and there's 18 bread rolls in each packet and there's 15 hot dogs in each packet, and Mary buys exactly the same number of bread rolls as hot dogs, so she's buying the same number, and the question says, what's the smallest number of each packet that Mary can buy? Okay, so let's consider the bread rolls. So for the bread rolls, she could buy 18. She could buy, if she buys 2 packets, she'd buy 36. That's a calculator question. So what I'm going to do is I'm just going to type in 18, press equals, and then just write answer plus 18. And that gives me 36, it gives me 54, 72, 90, 108, and so on. In terms of the hot dogs, they're sold in packets of 15. So I'm going to press 15, press equals, and then press answer plus 15. So that gives me 15, 30, 45, 60, 75, 90, 105, and so on. Now we've actually found a number that's in both of the lists, 90. Because she buys exactly the same number of bread rolls and hot dogs, and we want to find the smallest number of packets that she can buy. If she buys 1, 2, 3, 4, 5 packets of bread rolls and 1, 2, 3, 4, 5, 6 packets of hot dogs, then that would be the same number. That would be 90 of each. So that's it. So what's the smallest number of each packet that Mary can buy? The answer would be 5 packets of bread rolls and 6 packets of hot dogs. Okay, let's look at our next question, question number 14. Okay, let's have a look at our next question, question number 14. So question number 14 says that Helen thinks of two numbers, and the highest common factor of her numbers is 5, or the two numbers is 5, and the lowest common multiple of the two numbers is a multiple of 12. And we've been asked to write down two possible numbers that Helen could be thinking of. Okay, so we want to find two numbers that have got a highest common factor of 5, so highest common factor of 5. So in terms of highest common factor of 5, the two numbers then must be multiples of 5. So here we've got two numbers that are multiples of 5, but also they've got a highest common factor of 5 because by choosing 5 and 60, because 5, so its factors would be 1 and 5, and that then makes it quite a good choice. Okay, so here we've got two numbers, 5 and 60, and we're also told that the lowest common multiple of the two numbers is a multiple of 12, such as 12 or 24, 36, 48, 60, and so on. So that means for our two numbers, if we were to write down their multiples, that the lowest common multiple must be one of the numbers in this list, if we could carry on as well. So what I'm going to do is I'm going to consider the numbers 5 and 60, because with 5, the multiples of 5 would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, and so on. With 60, the multiples of 60 are 60, and as you can see, 60 is in both of the lists. So that means that the two numbers 5 and 60 would have a highest common factor of 5, that's the biggest number we can divide them both by, and also they would have a lowest common multiple that's a multiple of 12, because 60 is a multiple of 12. So that means that would mean that 5 and 60 would be two numbers that Helen could have thought of, so 5 and 60. And that's it. Now there is another part to that question, and that's to consider product of primes, and there's more questions like this in the product of primes booklet, and I would use the Venn diagram to help me out to work that out. Okay, let's have a look at our next question, question number 15. Okay, so question number 15 says, trains leave Bristol to Cardiff every 15 minutes and to London every 21 minutes. And a train to Cardiff and a train to London both leave Bristol at 11 a.m. And the question is, at what time will a train to Cardiff and a train to London next leave Bristol at the same time? So what we want to do is we want to find the lowest common multiple of 15 and 21. So let's do that. So 15, so we've got 15, 30, 45, 60, 75, 90, 105, 120, and so on. In terms of the multiples of 21, they are 21, 42, 63, 84, and 105. And as you can see, 105 is the lowest common multiple of 15 and 21. Now we know that the trains left Bristol at 11 a.m, the train to Cardiff and the train to London. So we need to find what time this would be. So 105 minutes. So 105 minutes is 1 hour and 45 minutes. So 1 hour and 45 minutes, that's 60 plus 45 is 105 minutes. And then if we add that on to 1 hour 45 minutes onto 11 a.m, that'd be 12:45 p.m. So 12:45 in the afternoon, or 1:45. And that's it. Okay, let's look at our next question, question number 16. Okay, let's have a look at our next question, question number 16. So question number 16 says that Jessica writes down two numbers, A and B, and A is an even number and B is a multiple of 3. And we're told that the highest common factor of A and B, these two numbers, is 25. And we've been asked to write down the possible values of A and B. Okay, so what I'm going to do is I'm going to think of some numbers that may possibly work here. Now it says that the highest common factor of both of the numbers is 25, so I'm going to think of numbers that have got a highest common factor of 25. So that means that they're going to be multiples of 25. So I'm thinking perhaps let's choose an even one. So an even one, let's just choose 100. So e.g., let's let A equal 100 because it's even. And then the other one needs to be a multiple of 3. So we want a multiple of 25 that's a multiple of 3. So I'm thinking 25, 50, 75. So B is equal to 75 because it's a multiple of 3. And let's just check that. Is the highest common factor of 100 and 75 equal to 25? Well, the factors of 100 would be, so the factors of 100 would be 1, 2, 4, 5, 10, 20, 25, 50, 100. The factors of 75 would be, 1, 3, 5, 15, 25, and 75. And the highest common factors of both of those two numbers is 25. And A is an even number, so it's even. And 75 is a multiple of 3. So that means that would work. So A is 100. And B 75, and that's two possible numbers that I've chosen. Okay, let's look at our next question, question number 17. Okay, so question number 17 says that trains to Portadown leave a train station every 28 minutes, and trains to Portrush leave a train station every 16 minutes. And the question says that a train to Portadown and a train to Portrush both leave the train station at 8 a.m. And the question is, what time will a train to Portadown and a train to Portrush both leave the train station again at the same time? So what we want to do is we want to find the lowest common multiple of 28 and 16. And I'm going to use my calculator to help me do that because I don't remember 28 times tables off by heart, so I'm going to use my calculator to work those out. Just keeping on adding on 28 each time. And then what I'm going to do is I'm going to see how long that takes in minutes, but remember we want to find what time, so that's going to be, we're going to look at the 8 a.m. and then work out and add the time on to find out what time the trains will leave to go to Portadown and Portrush at the same time. So in terms of Portadown, the trains to Portadown leave every 28 minutes, so the multiples of 28 are 28, 56, 84, 112, 140, and so on. In terms of Portrush, trains to Portrush leave every 16 minutes. That's 16, 32, 48, 64, 80, 96, 112, and so on. That's a calculator question, so that's quite nice. You can just add those on each time. And as you can see, 112 is in both of those lists. And that would be 1 hour, that's 60 minutes. There's 52 left over, so 1 hour, 52 minutes. And if we add that on to 8 a.m., that'd be 9:52 a.m. And that's it. So that's the time that trains will go to Portadown and Portrush at the same time again. Okay, let's look at our next question, question number 18. Okay, so let's have a look at the next question, question number 18. So question number 18 says the highest common factor of two numbers is 6, and the lowest common multiple of the same two numbers is 60. And we've been asked what are the two numbers. Okay, so what I'm going to do is I'm going to start considering some numbers, and we know that the highest common factor of the two numbers is 6. So perhaps if 6 is one of the two numbers, that would be quite a good choice. So I'm going to choose 6 as one of the numbers, and then I'm just going to have a look and see will these numbers work. And then we're told that the lowest common multiples of the same two numbers is 60. So I'm going to maybe think, well, could 60 be one of the numbers? And let's just see would 6 and 60 work. So 6 and 60, and that's what we're trying to work out. Would 6 and 60 work? So for the highest common factor of 6 and 60, if we write down the factors of 6, they would be 1, 2, 3, and 6. I'm just going to put some commas in there. And the factors of 60 would be 1, 2, 3, 4, 5, 6, 10, 12, and so on. There's quite a lot of them. And as you can see, the highest common factor of both of those two numbers would be 6. So the highest common factor of 6 would work. So that's fantastic. And I just chose 6 as a start number because if the highest common factor of the two numbers is 6, if I choose 6 as one of the two numbers, that might work in this case. In terms of the lowest common multiple, well, we're trying to find two numbers where the lowest common multiple is 60. Now, if we were to consider the multiples of 6, they would be 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, and so on. The multiples of 60 would be 60, and that's why I've chosen that because it's the first one. And as you can see, 60 is the first number of both of those lists. So the lowest common multiple of those two numbers would be 60. So then that would work. So what are the two numbers? Well, the two numbers that I've chosen are 6 and 60. And that's it. So they're the ones that I've picked. Okay, let's look at our next question, question number 19. Okay, so let's have a look at our next question, question number 19. So question number 19 says a red light flashes every 3 seconds. That'll be 3, 6, 9, 12, and so on. A yellow light flashes every 8 seconds. So that would be 8 seconds, 16 seconds, 24 seconds, and so on. And a green light flashes every 11 seconds. So 11, 22, 33, 44, and so on. And they all flash at the same time. After how many seconds will they all flash again at the same time? And this is a calculator question which is quite handy for this one. So in this question, you could write down the multiples of 3 and do 3, 6, 9, 12, and so on, the multiples of 8, the multiples of 11, and find the first number that appear in all of those lists, and that's totally fine. Or another approach is, if you've looked at product of primes and how to use Venn diagrams to find the lowest common multiple, that can be quite useful, particularly for this question here. It's quite a nice way to look at it. So one approach is we could write down a list of all of the multiples of each of these numbers and look for the first one. Another approach is to consider the product of primes and Venn diagrams. That's probably the approach that I would use for this question. But in this booklet, we're not really looking at product of primes. So another approach that we could do is, I'm going to find the lowest common multiple of 3 and 8. And what I'm going to do is I'm going to find the lowest common multiple of 3 and 8 because I know that the lowest common multiple of all 3 of these numbers has to be in all 3 of these lists. So we focus on the numbers that are in the list for 3 and 8, and we can list those down and find the first one that's divisible by 11 because that'll be the first number that's in all 3 lists. So in terms of 3 and 8, we've got 3, 6, 9, 12, 15, 18, 21, 24, and so on. 8, we've got 8, 16, 24. So 24 seconds is going to be the time that those two flash at the same time. And that means that they would also flash together at the same time at 48 seconds, another 24, again at 72, and so on. So what I'm going to do is I'm going to write down the multiples of 24 because the red light and the yellow light will flash together every single time the seconds is a multiple of 24. And we're going to find which one of those is divisible by 11, the first one that's divisible by 11. Because, for instance, we know that 24 seconds isn't going to be in this list here. So the multiples of 24, multiples of 24 are, I'm just going to use my calculator to work these out. So it's 24, 48, 72, 96, 120, 144, 168, 192, 216, 240, 264, and so on. And I've stopped there on purpose because that was the 11th one. And if you try to divide these by 11, well, I know 11 times tables are going to be 11, 22, 33, and so on. So no, so no. 121 is in the 11 times table, so it's not that one. So I'm just typing in 121 and then doing plus 11. So 132, 143, nope, 154, 165, 176, 187, 198, 209, 220, 231, 242, 253, 264. So 264 would be a multiple of 3. It's divisible by 3. It's also divisible by 8. It's in the 8 times tables. And it's also divisible by 11. And it's the first number that would appear in all 3 of those lists. Now, in terms of this question, I probably would use what we call a Venn diagram. And if I was doing that, I would realize that I could just do 3 times 8 times 11, looking at the Venn diagram for that question. But that's how I would do it if I hadn't encountered that Venn diagram on the product of primes. And that's it. So the answer is they would flash again all at the same time after 264 seconds. And that's it. Okay, let's have a look at our last question, question number 20. So question number 20 says, last year, James started collecting minifigures and he displays them in cases. And a bag of 6 minifigures costs £15, and each display case holds 16 figures and costs £9. And last year, James bought enough bags of minifigures and display cases to have between 50 and 100 minifigures. So he's got between 50 and 100 minifigures, and he filled every display case that he bought. So he buys these display cases that hold 16 figures, and he's filled every single one of them. And the question says, work out how much money James spent on his collection. Okay, so what I'm going to do is I'm going to start by considering the display cases, because we know that he fills every display case that he bought. And each display case holds 16 figures. So let's consider the multiples of 16. So 16, and then another 16 would be 32, another 16 would be 48, and then 64, 80, 96, 112, and so on. Now we know that he's bought between 50 and 100 minifigures, and he fills all of these display cases. So he's filled all the display cases. So he hasn't bought one display case because he's bought between 50 and 100. He hasn't bought 2. He hasn't bought 3. He could have bought 4 display cases. He could have bought 5 display cases, or he could have bought 6 display cases, but he hasn't bought 7 because that's too many and he hasn't bought enough minifigures to fill them all. Okay, so he's either bought 4, 5, or 6 display cases. Okay, now, he buys these bags of minifigures, and these bags of minifigures contain 6 minifigures. So what I'm going to do is I'm going to have a look at these numbers and I'm going to see, are any of them a multiple of 6? So are they a multiple of 6? So multiple of 6, because we know that each bag of minifigures he buys contains 6 minifigures, and he displays all the minifigures. So to see if they're a multiple of 6, I'm going to divide them by 6, and if I get a whole number, then I know it's a multiple of 6, or if it's a decimal, then it's not. So 64 divided by 6 is 10.6666, and so on. So he hasn't bought 64 minifigures, because if he bought 10 bags of them, that's 60. If he buys 11, that's 66. So he can't buy 64. 80 divided by 6 is equal to 13.333, and so on. So that's not a multiple of 6. So 13 bags of minifigures is 78, and 14 bags is 84. So it's not possible for him to have bought 80 minifigures. Okay, next, 96. If we do 96 divided by 6, that's equal to 16. Now 96 is a multiple of 6. So that's fantastic, because 96 is a multiple of 6, and it's also a multiple of 16. So that means it's possible for him to buy so many bags of minifigures. And if we do 96 divided by 6, 96 divided by 6 is equal to 16. So if he buys 16 bags of minifigures, then that would be 96 minifigures. And if he buys 1, 2, 3, 4, 5, 6 display cases, then that's what he's bought. So he's bought 6. So he's bought 6 display cases and 16 bags of minifigures. So that's what James bought. So that's what he's bought over the last year. 16 bags of minifigures cost him £15 each. And he's bought 6 display cases that cost £9 each. So let's work this out. 16 bags multiplied by, and then the question we're told that each one costs £15. So that'll be the price of the minifigures. And he bought 6 display cases, and each one of those costs £9. So if we work out those multiplications and add them together, that's the total amount of money he spent over the last year on his collection. So 16 multiplied by 15 is equal to £240. And 6 times 9 is equal to £54. And then if we add those two together, that's equal to £294. So that means that James has spent over the last year £294 on his minifigure collection. And that's it. So these have been the video solutions to the Corbettmaths practice questions on the lowest common multiple, or the LCM, and the highest common factor, the HCF. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. If you found these sets of questions useful, particularly these ones, I would also recommend you look at a topic called the product of primes, and also how to find the lowest common multiple and the highest common factor by using the product of primes. And that's what I would probably look at next. And that's it. So thanks very much. Cheers. Bye.